Hello my friend, welcome to another video. Today I'm starting a new series on Leetcodes. A dear friend suggested me, well, if you want to get into a big company, you need to do this stuff. And I'm gonna do it with you in YouTube so we can do everything together. Alright, we start from this exercise that I think is simple. It's good to break the ice, and which is check if two string arrays are equivalent. Basically we have an array of strings, like in this case, and the strings are equal if the concatenated strings basically are equal. You see? Of course I cannot use the string compare here because this is an array of string. So here I basically have also a prompt, a suggestion for the actual solution, which is the one of concatenating all the strings which are inside the array and then making a string compare to that. Arguably this is not fast, but we're gonna see eventual solutions. All right, these are not equal, ACB, ABC, of course, and these are equal, ABC, D, DFG. Here I have the actual constraints, so I have word length. Here I have the prototype of the actual function, which contains the actual array of strings, and word one size, word two size. So basically this is the number of strings, I guess. Word one size is, for example, here is gonna be 2, and here is gonna be 3, and everything is in lowercase. Okay, I'm gonna solve this in Vim, my lovely Vim. All right, let's do our main.c. I'm gonna copy the prototype, and we're ready to rumble. So immediately I'm gonna include stdio for the printf. Then I'm gonna include standard boolean. As you can see from the prototype, we are using boolean values. Okay, this is the scenario, right? We have an array of strings, right? And these two things, these two array of strings are equal because ABCD is equal to ABCD. So my idea is basically to do a concatenation. So I'm gonna concatenate, I get ABCD is equal to ABCD. Here, of course, I'm gonna use a string compare function. Okay, like that. So basically concatenate and perform a string compare is the actual solution, which is of course not the best, but it works. So let's start with this. So first of all, I wanna get the len of strings. Basically I want 4, right? Because A, B, C, D is 4. So I want this len here. So I can malloc this len, and then I'm gonna copy the actual string there. I have to do this for both strings. So let's declare two variables, which are int len1 and len2. And I say len1 is equal to len2, which is equal to 0. This is the cascade assignment. I can do that because the assignment operation is going to return me back the actual value assigned. So this is going to basically become a 0, which is going to be assigned to len1. So we do for int I equals 0. I is minor. Here we're going to use the actual word one size, right? Plus I. You want to accumulate in len1 plus equal the len of the actual high string, right? A, B, C, D. So I need to include string.h. So include string.h. So here we can use the actual function string len, which is word 1 in position I. Beautiful. I do the same exact thing for the other string. So word 2 size, len2, word 2, like that. So here we got the length of the actual two strings, ABCD, ABC, and D. Now I want to malloc the space to create my cat strings. So let's declare char star string 1 star string 2. Pay attention here that you have to use the star 2 times, because if you don't do that, you will get a char here, not a pointer. And you say string 1 is equal to malloc, even though it's better to use calloc. So we're gonna include the standard library, like that. So calloc that takes how many bytes, which is gonna be len1 plus 1 for the actual \0. And the size is gonna be size of char. To be pedantic, let's do like that, even though it's gonna be 1. calloc is handy because the space is gonna be filled with zeros, right? As you can see from the manual, right? Contrary to malloc, in which we can have other values, even though most of the times you will get all zeros. And having all zeros is pretty handy, you will see why. Of course, every time after a malloc function you control for null, so if null is equal to string1, you throw an error, p error, malloc failed, and you exit, like exit, I don't know, 42. Perfect. And then what do? Well, you are gonna concatenate all the strings inside this space which has been malloced. So you do a for int I equals 0, I is minor than word1 size plus I. You're gonna call the function string cat, which takes a destination, string1, and the actual source. Our source, of course, is gonna be every string inside my array of strings. So I have word1 in position I, right? So it's gonna be word1 square bracket I, like that. You see that having all the bytes here to 0 is pretty handy, because string cat, if we read the manual, is gonna append a copy of the null terminated string s2 to the end of the null terminated string1. You see? So having all zeros from the very first iteration is gonna make the string cat function start immediately from here. I don't have to worry about these zeros, right? All right, now we have our string1, which is ready. We have to do exactly the same thing for string2. So arguably it would be nice here to have a function to handle this, but let's keep it simple with only one entire function. I don't want to subdivide this. So string2, I just simply change the values here, len2, word1 size, word2 size, string2, word2. That's it. All right, now I have my concatenated strings. The last thing to do is just to make the comparison, right? Make comparison with string compare. So given that I have to free as the last step, right here at the fourth, I have to free the actual calloced strings. I need a variable, a boolean variable here, which is going to be return, and return is going to be equal to string compare, string1, and string2. Of course, the string compare is going to return me 0 if the actual strings are equal. This is because the string compare is going to return me the actual difference between chars. I made a video about if you want to dig down. So here I have to say equal to 0. So I saved the actual return. Now I have to free the actual strings to avoid memory leaks. So free string1 and string2. Last step, I simply return ret. So this is the total function. I get the len of the actual strings. I'm gonna use calloc, not malloc here, so let me change. Then I'm gonna make the actual comparison, stocking the value inside the return variable. Then I'm gonna free the actual strings, and then I simply return. 5 steps. Now here I have some simple tests in which everything should pass, because ABCD, hello world, everything is equal. So let's compile and launch, and everything is correct. Now let's do everything actually incorrect. So I'm gonna modify everything here, just changing a little char. Now everything should be wrong, and indeed everything fails. All right, so the solution works. 4 millisecond runtime, faster than 54%, which is not tremendously good, and memory usage is very bad. All right, let's try to do something better than that. So in this solution, I don't want any string concatenate in the heap. I will indeed use directly the string which are inside the array and search for charts which are different. Now it's tricky. While we are coding, it's easier to understand. To do that, I'm gonna declare some iterators which are index1, index2, and then char index1, and you guessed it, char index2. All these values have to be initialized to 0. So index1 is equal to index0, which is equal to char index1, equal char index2, which is equal to 0. Now I want to make a loop to do all the actual comparison. So here I'm gonna say while index1 is minor than word size 1 and index2 is minor than word2 size, like that. Here what is going on with this condition? Well, these index1 and these index2 are basically iterators which are in this position, so index1. So here I say while index1 is minor than word size, which in this case is going to be 4. So the condition holds in our example, of course, when index1 is equal to 0, 1, 2, and 3. And for this other case, index2 until is equal to 0 and 1, right? As you can see from here. So basically, in one words, what is this condition here? Here is written until I actually have strings, right? Until I actually have strings in my array. What do? I say immediately 1. If word1 in position index1, which initially is 0, and the char index1, which initially as well is 0, is equal to the exact same thing, just for the word2. So word2, index2, char index2. But here I don't want to do an equal. It's better to do a different. I say, if I stumble upon a char which is actually different, you're gonna return false, right? Because we are searching for a different char. So every time we're gonna check the actual char pointed, and if we stumble upon something which is different, we are out, we're finished. Now, the problem here is that we are dealing not with regular strings, but we are dealing with an array of strings. So what shall we do now? First of all, I'm gonna increase the char indexes, right? So very simply, I'm gonna do char index1 plus plus, as well for plus plus char index2. So we move actually to the following char. Then I have to check, is the string actually finished? Like that. Namely, I'm here, like I reached the \0, because if this is the case, we have to move to the following string. So we say if word1 in position index1 and char index is equal to \0, what do? Well, if this is the case, you have to move up, right? You have to move index1, you do index1 plus plus, right? And you have to refresh the actual char index because we go on the following string. So you do char index1 is equal to 0, a refresh char. Understand here what we're doing, right? Let's pretend we reached this position \0. So I have to move index1 in the following position, right? So basically we remove this and index1 becomes this. And then of course the char iterator has to be refreshed to 0. That's basically what is going on with this piece of code. We have to do exactly the same thing for the other string. So I'm gonna simply copy this and change the parameters, right? Word2, like that. So this is the loop. This is the loop. Basically the loop is true until we have both strings which are not finished. We do that exploiting the actual word1 size and word2 size. Then I check immediately, hey, are the actual chars pointed different? Because if this is the case, I want to exit the loop and return false. Then I'm simply moving the char. So I'm simply going to the following char for both strings. Then I simply have to check, hey, are we finished with the actual string? Because I have to move to the following one in that case. And we do that for both array of strings. Okay. So when the loop is finished, what do? Well, if the strings are equal, I'm going to return index1 has to be equal to word size 1, right? And the same, so index2 has to be equal to word2 size. If this condition is true, it means that the strings are actually equal, right? So this is the actual algorithm I'm thinking of. So I'm gonna just copy the main from the previous function and I'm gonna paste here. And let's try to launch. Now everything should fail. So I compile and launch. Everything fails. Perfect. Okay, now we are getting a very good improvement. Memory usage wise, as you can see, less than 91% of people. Arguably the code can be run much faster, but I'm okay with this solution. So if you have a better one, please leave a comment. I will for sure pin your solution. Thank you very much, my friend.